Alright. So today, I need to put it back. Right. It's broadcasting. Yeah, so today we will talk more about this abstract data types. Okay, in this week. It's all about abstract data types. It's the reason we want you to have a better understanding of this topic is because this actually helps you to learn the concept of object-oriented programming. All right, because that's about abstract, about how do we use this data types to abstract them into classes, into ADT, abstract data type, to solve problems. Okay. So, this is what we mentioned. We should have a specified ADT with 3 factors. And remember that I want to see those 3 factors, no matter it's in the midterm or in assignment. Okay. All right. So, first, it's a description of the elements that compose the data type. So, what is in there? Like an array, we talk about index and the data elements and the data block. Okay. Second, it should include a description of the relationships between the individual components in the data type. Okay. So that's the array, right? So we use the indexes help us to retrieve all this data in the data block. And also a description of the operations that we wish to perform on the components of the data type, right? All right, so that's 3 things: operations, elements, relations of the elements, and the operations. All 3 of them. I want to say all 3 of them when you are finish your homework and midterm. Okay, so remember we talk about this hierarchy. What's the abstract data type? Let's go from the lowest level. Okay, so the computer architecture hardware level, bits like 0, 1, 0, 1, 0, 1. That's what they all become eventually in the computer. They're represented with 0, 1, open, close in the electric parts. And also the level above it is the assembly, right? Remember that this assembly is the a set of instructions that can be used translated by the compiler from higher level language to that. So if you know the assembly language and the implementation high level language, think about Java, C, C++, C#, those things are in this level. And on the top is the definition. Okay, so that's why when we learn this data structure, some of us learn them in with C. Some of us learn the data structure with Java, right? So I believe you learn with Java.
I'm learning Java.
Yeah. So I learned my data structure in C. So yeah. So that's that's because that doesn't matter, because the actually language implement them is a level below it, but the definition, the meaning, the usage of the ADT data structure is a level up, is at the highest level. Okay, so if we want to figure out how we use those data structures, it doesn't matter what language we select. So that's the ADT array, right? We talk about it. It shows index, range, collection of data item, and range is the collection of the consecutive enumerated values, and associated between the index, range, and the data allows us to design the designate the first value in the array. So it describes the relations, the elements, the relations, and the operations. And when we define the operations, remember we do it with precondition, postcondition, right? And also we can describe what the operation will do, and we specify. Also, we can specify them with those figures. Yeah, and I ask you. Last class I asked you to define which one, the stack, right? Yeah, to do the stack. Okay. So we will do some exercise. Let me do the stack. For you. Okay. I think I use this type of thing. Alright. Okay, when we are playing with stacks, usually it's this type of we play with this type of scenario, right? So if I want you to write a code to solve this problem, or solve any problem, any equations that with the parentheses, right? You will need the help from stack, right? But how do you use stack to solve this problem? Yeah, that's what I told you, is we need help from stack, but how? How will stack help us solve this problem?
The fact that we know that the last in will be the first out in a stack makes us think about the position each value.
Yeah. Okay. Yeah. So that's the keywords I'm looking for. The last in, first out. Okay. So here we want to match. We want to match the parentheses. We want to match the parentheses with each other. So obviously here we know we need to match this one with this one, right here, and we want to match this one with this one, and this one with this one. So it's easy. We can just visually solve this problem. But for computer, if you are not using computer vision, you just want to solve the equation, you need help from the stack. So how do we do that from stack, right? Remember the keywords: first in, last out, right? So let's draw a stack. Right. Remember when we have stack, it's just like a stack. We put things on top of each other. So here is a stack. This is a stack. We just put one on top of each other. Wow, okay. Maybe this should be the same size. Okay. So here, when we read a parenthesis, a left parenthesis, the left, we just push it to the stack. Okay. So the first, so when we read this, we push them into stack, the left one. And we read the second left one, we push it into the stack. Alright. So here in this case, we should have 2. Yeah. 2 things here. But okay, so this is obviously not here now. because it should be empty. When we read to here, suppose this is a stack. Okay. So we put the first one here, second one there. Right. Alright. So what we do is we keep reading. We keep on reading. Yeah. When we read to a right one, this one over here. Okay, what is the operation we need to do?
Pop.
Yeah. What was that?
Then we're gonna have the operation stack and the output stack.
Yeah. So, well, there's a word called pop, right? So, what is a pop operation? Pop operation means we take one thing out of the stack, and it should be the element on the very top. Okay. So after the pop, the elements won't exist in that stack anymore, right? So just this left bracket, we have this right bracket here. Whenever we read a right bracket, we know there's a match, so we just pop the left bracket here. Okay, so when we read this, okay, and we pop this one, so we find a match. We find a match here. Okay, and then we keep on reading. We read the second right bracket, and then it will be matched with this first bracket. Okay, so that this is how it find match with the stack. And also after we pop this one, we will read another one later on, this left bracket again in this stack, and it keeps on reading. When we read the last right bracket, it will be matched with the one right here. Okay, so that's how the stack help us to solve the match of the parentheses. Yeah. All right, so now given that functionality and the application of the stack, now let's try to define the ADT of the stack. Okay, so it doesn't matter which language. All right, we just want to define element, relations, and functions. All right, let's see. Stack ADT. First, we need a definition. Everything becomes big. Well, you can read, right? This is big enough. Okay. First, we give a definition, right? So what are the elements of the stack?
Some other object.
The elements. What's included in the stack? Object. I think we can call data items like what we do for the array, right? Yeah. And yeah, so any other attributions, any other things like the stack? Well, when we have a stack, we have a stack of something. We have a stack of brackets, or we have a stack of, maybe we stack all the chairs together, right? But do we stack a car on top of chair?
So they have to do the same.
Yes, exactly. So it's gonna be first, it's gonna be a collection, right? It's a collection of data items, and the data should be identically typed, right? And let's see, it's a collection. First, it's a collection, identically type, elements or data elements, data type, data elements, data items, anything. Just say elements, it's fine. And what else? Just a collection. That's it. Of identical type. That's it. Is that it?
One will stay on top of the other.
Yeah, exactly. That's an important feature of stack. So one are on top of another. Okay. One on top of another. Right? Yeah. And okay. One on top of each another. So any other things we want to mention about stack?
The behavior is first in, last out.
Yes, exactly. We want to, this first in, last out, and we want to explain first in, last out. First in, last out, maybe, maybe for the person who never heard this term before, you don't understand. But we want to specify what is first in, last out. Okay, so first in, last out means when we place a new item, right? When we place the new item, the new element. Since we use element, so here we also use element. New element. We place a new item, new element on the top, right, of the stack, right? Also, when we remove, right, that's first in, last out. When we remove, we take it off the top of the stack. Right, so that's basically explain the first explain what are those data, these elements there, right? And then it explains the relations. Actually, it's first in, last out is their relation. So we explain in more detail. So when we place it on top of stack. When we remove it from the top of the stack. So that makes sure it's first in, last out, like last in, first out. Okay, last in, first out, same thing. All right, so that's the definition, right? So two things we fixed here, or two things we solved here is the elements and the relations here. And then how about the operations? Yeah, so we push. Operations. First, we need to have to push, right? And object X. So what I want to say is you put the explanation of that method, okay, the operation. So it's insert object X at the top of this stack, right? And also I want you to specify the precondition and post condition for that operation. Okay, and then if possible, we need a figure. Well, let's think about the pre and post condition when I was trying to make this figure. The precondition and the post condition of push. do you think? The precondition and the postcondition of push.
The stack is already constructed. And this can be empty or not.
Yeah, it doesn't matter actually if it can be empty or not. So it's not precondition, right? So I think the only precondition is we created a post. Well, there's
Stack has to exist.
exists a stack, and postcondition is the x should be on top at the first element of the stack. It's the top element of the stack. Okay. So what we can do is just use the figure to demonstrate that. I think figure is a pretty good way to explain things in data structure and make things visible. Right. So it's gonna be, this is a stack. It's an object, right? And we have a new item. Object X. This is the object and named X. Okay. So what we want to do is here. Well, so we call this before. Right. This is before, right? X, we have a object X there, and we have a stack there. It doesn't matter it's empty or not, but in this case, it's not empty. And after that, and that's a before, and the post after that. Okay, we'll have a stack, but with the object X on top, right? And we tell others it's actually after. Okay, so we can use this figure to demonstrate this. What's actually going on? Okay, so that's the operation of push. And what else do we have here in stack? Yes, pop. So that's pop. So explanation. Can we describe this pop? What do we do?
Remove an object at the top of the stack. Remove the top object of
Yeah.
the stack.
Yes, but one thing, remember, we remove but we return it. We return. So this operation, it has return value. So we remove that object. We are not destroying it. We return it to the any statement that calls this pop operation. Okay. So just we remove and return the object at the top of the stack, right? And also you can do pre-condition, post-condition. Pre, post, blah blah blah. It's gonna be something similar. Okay, and can we do something else?
Besides,
Actually, is it good to always use pop? Because pop, yes, it's well the main functionality of a stack. It just take it out there, right? But it take it out. What if we don't want to take it out? We just want to know what is there, right? 'Cause if you have a stack of something, well, you can see, right? I have a stack of book. You can see on top which book is that, right? So here we want to simulate that. So we need a peek function. We need a peek function, right? It just, what's the difference between peek and pop? Yeah, it just return. It doesn't remove, right? So I'll just copy paste. It'll return the object. Right. Pre, post, blah blah blah. If you think it's necessary, you use a figure, but this is clear, obviously clear. You don't need a figure to explain that, right? Okay, so that's well, the stack operations. So, well, the thing I want you to remember is important 3 elements. The describe the elements. Sorry. The 3 elements I want to have in ADT is first describe the data item, then describe the relations, third describe the operations. Okay, so that's about stack. Yeah, now let's try something else. Okay, stack is pretty straightforward. Let's see if you can define something else. All right. This time we will define a dictionary. Yeah. Definition of dictionary. You know what? The dictionary is also data. It's not the dictionary. Yeah, it's similar to the dictionary you are looking, but well, in terms of data structure, abstract data type, what is the dictionary? What is included in dictionary? First, let's see what data items are there.
Key.
Key and value, right? Keys and values. That's 2 collection, right? 2 collections, key and values. So what are the attributes of key and values? Think about key and value. Yeah, you cannot just say, well, just saying key and value, you get part of the points, yes. But it's not complete yet. What's the attributes of key and value? What's that? Mapping. Yeah, that's the relation. That's the relation. We are not there yet. Okay, we are still describing key and value. Okay, think about more details about key and value.
You mean the type? When you say attribute?
Yeah, type is one thing, but it's not the main concern here. The main concern here in the dictionary is,
So, like saying key is actually the position, something like that?
well, the position is actually doesn't matter.
Store items by key.
Yeah, that's the relation of a key and value. Yeah.
Key is the character and value is string.
Value can be any value actually. It doesn't have to be. It doesn't always have to be string. So one of the things we overlooked is the key. What makes a key a key? They have to be unique. They have to be unique. You cannot have 2 keys where they are the same, right? Keys like your student number. You have student number mapping to your whatever profiles, your informations, right? Your record. but your student number is the key, which is unique. So you want to catch this point. Okay. So dictionary. Stores a collection of the unique keys and their associated values. Okay, and we want to each key to associate with one single value, right? So that's what we mentioned that a lot, the association, yes. But don't forget, there are some attributes there describe the data item we want to bring it in the definition. Yeah, this is the part that can be easily catched. Each key is associated with a single value. Yes. Alright. How about the operations? How about definitions? No, operations, sorry. What do you do with the dictionary? Most common one is see here, we get a key from, I will get a value with a key, right? Yeah, we put, correct. Right, we put. So we cannot just get the key before we put, yes. But the thing why we are having the dictionary is we want to get the value with the key. We want to get your information with your student number. So let's first define get. Okay. That's a key. We have a key K. Then what it do is it return the value currently associated with the key K. Is that all? Does it describe everything that get will do? Okay, well, there's some situation here, some special situation is if you just make up a number, student number there, maybe it's not associated with any of the value. So is there circumstances that if K is not in the map, we just return a non-value. Right. Okay. And here, let's try to define the precondition. First, we also know that first the dictionary is there, right? Second, I'm sorry, I should here I should say object K. So if that's the case, here we also need to make sure K is of the type key. Right? Try to, or you can just give some random things to retrieve any things there, right? Okay. And post condition is it return null or the value. Okay. Alright. And we cannot get without put, right? So definitely we will need another put. Right, so object K and object V. Alright, and what we want to do is so the put so we just place, right, the V in the map with a key K, right? That's put, how we put, just put associate number, right? And how about, what, is there any other situation we need to take into consideration?
The value is already in the map.
Yeah, you are on the right direction, yes, but value is okay actually. We can have this, well, maybe Tom associated with a key, another Tom associated with another key. That's fine. Well, we have a Tom, maybe two students have same name. That's fine, right? But they have different key. They have different student number, so that's fine. Yes. But what else? Can you put a key that already exists there? Then how do you do that?
Just cover the first.
Yeah, I mean you update, right? Well, it depends. Sometimes it depends on how you want to use that. Sometimes you have restriction, like you cannot just put in the key that already exists, or it can be the put. It can be just combined with update. So if the key exists, if K has a value already exists, it is replaced by V. Okay. If K has a value already, it is replaced by V. So kind of like update. Alright, and some of the precondition, post-condition we can think about them. And okay, so here we may want to well, let's try to use a figure to explain what is a dictionary. Oh, this is the okay, let's do a dictionary. Let's assume this is a dictionary, okay, and we have several keys. Let's assume we don't have a. Let's assume the names are the keys. Okay, we want to use the name to find the phone number. That's what we do in the directory, school directory. Actually, we can use a name to find the employee's office phone number. So here we can say Joe with the phone number 770 blah blah blah, and we can have another key, James, right, and 404, something like that. Okay. And also we have another cell. It should have a key and a value. It has to be a pair. Okay. So in the put function we have 2 parameters. So it could be Bob with the phone number. It's maybe 210 blah blah blah. Okay. And we want to specify this is the key. No. And this is the value. Okay, key and value. And what do we do is we're trying to put it here. We're trying to put this key value pair to that dictionary. Okay, so that's before. And after that, it's gonna be similar. So this is gonna be very clear to demonstrate it to those who read your documentation of the abstract data structure. Yeah. So this is after. Okay, so that's, we use a figure to demonstrate this put there. Okay. And then that's a put. Usually there are a lot more functions in dictionary. Like when somebody left the school, he may went to another school, graduate. We may want to remove, right? Remove the information from the dictionary. So when we remove, what do? Do we need 1 or 2 parameter? When we remove, what do we use as a value we passed?
Just the key.
Yes, exactly, because we can find the key, right? Why we don't need that value? So it's just remove a key value pair. Remember, when we remove, we do not only remove the value, we also remove the key, right? Of course, it's associated with the key. Okay. Also, we want to clear everything, right? So I'm not specifying everything. Also, we want to check if we have that contains key, right? We use the object k. And also we check if that contains value. Object v. Yeah. And also, usually we define another 2 essential functionality in dictionary is we want to get the whole set of the key and or the whole set of the value. So we want a function that returns Joe, James, Bob. We want another function returns numbers 770, 404, 210, something like that. So it's key set, which returns the key, the set of the key, or value set. Okay, so that basically are the dictionaries. Okay, so that's most typical functionalities of a dictionary. Okay, so what I'm specifying this is not like I'm trying to push you to remember the functions of the dictionary. Just give you examples of how do we try to describe the data types. Okay, abstract the data types. All right.